Whoa. All right. Hello, everybody. Welcome back to Comp 2452. As I promised last week, today is our last lecture class. So reminder, I suppose, on Thursday, I will be in this room. Like, I plan to come here, but I'm just going to sit here with my laptop. And I kind of welcome you to treat this as open office hours if you have any questions about anything course related. But I'm not going to be giving a lecture. There won't be a live stream. Today is functionally the last class that we would be having together for the course. And functionally being the last class, that means that so I've been teaching here for 10 years. I've been this is my 10th year teaching here. This was when lots of you were in grade 8, I guess, when I started. I think that's about right. I think that's about right. 10 years ago. That's about right, I think, yeah. 7, grade 8, something like that, yeah. You were in middle school. This is the first time I've ever taught a group of students twice in 2 terms. And so this is, I don't know, this has been a really kind of cool to see how you have all progressed from basically like Comp 1020, I don't know, young adults to like second year young adults and going into third year young adults. This is super unrelatable, I realize. This is like your parents talking to you about how you've gone so far since kindergarten, and here I'm talking about like I don't know, 6 months worth of time, but I don't know. I'm really just trying to say, like, this feels kind of cool for me to see how you have all functionally changed in terms of what you're able to accomplish from the beginning of last fall. In today's class, what I really want to do is I want you to be able to know a little bit more about courses after Comp 2450 and 2452. I've tried to build this a little bit into the review topics that we're going to be looking at today, but I want to look ahead and kind of see how some of the learning outcomes that we've been touching on throughout these 2 courses fit into courses that are in the 3rd and 4th year and beyond. So I've listed some grad level courses that you might see in terms of the topics that we're thinking about, but also thinking about how these things might fit into your day job. I want you to be able to know a little bit more about the final exam. So I promised to talk about the final exam today. I'll have an opportunity for you to ask questions about the final exam. As with every test that you've seen with me before, my very strong preference, if you have questions about the test or the exam, is to ask them at a place where everybody has access to the same answers. So either today in class or after today on the course discussion forum. If you email me questions about the exam, I'll politely ask you to ask those questions on the course discussion forum. This is as much as anything else to say, keep an eye on the course topics or course material discussion forum after the class is over, just in case people are asking questions about the exam there. But please expect to know a little bit more about the final exam after today. And then finally, what I want to do is spend a little bit of time doing review. So I picked the top 3 topics that were ranked in the last class that we did together. And I put some slides together about that, and some Mentimeter slides that are mainly for you to have a chance to ask questions to me about stuff. So first things first, hello everybody, welcome back to Comp 2450. So on December 3rd, last term in Comp 2450, I gave you this, and what I wanted you to know about on December 3rd of fall 2025 in Comp 2450 was I wanted you to know a little bit more about Comp 2452. And so Hello, everybody. Welcome back to Comp 2452, but now I want you to pretend like we're in 2450 again, and we're talking about what's going to happen in Comp 2452. What I wanted you to be able to do at the end of that lecture, tentatively, was to do things like know what programming language we're going to be using, know what environment we're going to be using, know what learning outcomes you're going to be expected to demonstrate by the end of the course, and kind of have a sense of where we're going to be at. So 6 months ago, the language and environment that we were working with in Comp 2450 really was that we were kind of continuing off where we left in Comp 1020. So we were using Java. We were doing all text-based UI. So everything was using scanner. Everything was using system.out to produce it, to get input and to do output. And the persistence that we eventually got to in that course was to do text-based persistence. So writing our state out to files using something like JSON. To accomplish all of that, we were using a layered architecture. And this, I think, might have been the class that I revealed the big picture behind what we were doing. And this is actually an architecture that we're using to organize the software that we're building. So we use this layered architecture for the course. In Comp 2452, we entered the 20th century, and we really added some basic UI stuff. So welcome back to 1985 here. Everything that we're going to be looking at is local in the course. And so what I promised that you would do in this course last term was we would use build and dependency management tools. And all of you now have lots of experience, I think, using not just Maven, but also now adding dependencies with NPM, installing dependencies with NPM, and running your software and test suites with NPX. And so I think that we've accomplished that. Big check mark beside that one. We're not going to use application frameworks in this course. And so while I know that many of you know about things like React and Vue and Angular, I told you we weren't going to use any frameworks for software development, application development purposes. And we stuck to that. We built our own MVC implementation. We started from basically nothing, and we put together something that is an MVC architecture application. I did promise that we would use SQL for persistence, and we did that. Big check mark beside that. We did not use SQLite, though. We used PGLite instead. I will say that SQLite is another reasonable alternative to use for what we were trying to accomplish. But the reason that I chose to use PGLite for us this term was the setup story for SQLite in the web browser was painful. With PGLite, we did pglite.create, and then we just could run SQL queries on it. To do SQLite, the setup was about 15 lines long, and that was just to get something that resembled a connection to the database. And so I feel like PGLite was the right choice, even if it forced my hand with asynchronous and concurrency and stuff. But we accomplished use SQL for persistence. We're no longer just putting stuff into plain text files. We're actually using structured queries to put stuff into persistence. And the last thing I said was use HTML plus CSS here for graphical user interfaces. We're not using Canvas, and we accomplished that. A lot of your UIs, I'm saying this very politely because I'm saying this about myself as much as I am you. A lot of your UIs look awful. They look terrible. They're just basic HTML, and they don't do any styling. And as far as I know, none of you have lost any credit for that because that's not something that we're assessing in this course. To many of your credit, lots of your UIs look amazing. They look really good. And I think that in some cases, that's because you maybe know about stuff from outside this course in terms of CSS. That's cool. You're using AI for CSS. That's fine. You're doing something to make it look a little more stylish. That's amazing. And I think that's great. But the emphasis that we were looking at in terms of where we were at in Comp 2450 was, I want you to use HTML. This is the front-end tool that we're using to build GUIs for this course. And we were merging together TypeScript and HTML to accomplish that task. The very last thing I said was we're going to use a test framework for testing, and we've accomplished that. You've been using vtest to do all your testing. You don't have to write that test harness anymore. You don't have to copy and paste my terrible test harness. The test harness that you get with vtest is so much better than what I gave you last term. It's incomparable to look at the two of them. And so I feel like, what I promised to you that we would do last term, we have accomplished all of that. We've accomplished all of that. And I don't know, I feel good about that. All right, so now actually back into actual Comp 2452 in winter of 2026. I want to spend a little bit of time talking about the final exam. And so I'm going to give you a chance to ask some questions here. So I'll leave this up while I am talking about the things that I want to tell you about. But what you should expect for the final exam this term is it is going to be 2 hours long. This is scheduled by the registrar's office. This is a link here to the final exam schedule. I'm going to invite you to look at that, but our exam is currently scheduled for Wednesday next week at 1:30 p.m. I believe. But I'm not going to open up the exam schedule to check that. I'm going to ask you to do that on your own time so you can see what it is. As with the last final exam that you did in 2450, and as with the 2 term tests that you've done in this course, seating is going to be assigned. Your name will be printed on the final exam. I'm going to be sending you an email the morning of the final exam with your seat assignment. If you are scheduled to write your exam in an alternate location with Student Accessibility Services, the exam with your name on it will be provided to you by the person invigilating your exam. If you're coming to the exam hall to write with everybody else, please make sure that you're sitting in the seat that has your name printed on it. And I'll send that email out to you in the morning of the exam. The format that you should expect for the final exam is going to be consistent with the term tests. The final exam is cumulative, but the structure of the exam should be similar to the term test structure. That means that you can expect things like written answers, some shorter written answers. You should be able to expect some programming concepts to show up on this final exam. But pseudocode is okay. And if there is any view-related stuff here, what I'm going to be looking for is console.log. And I'm hoping that based on the first term test, you have a clear idea of what I mean by the view is console.log when I'm thinking about the view is console.log. Please do not memorize HTML. While I did promise that we would do that, and we have accomplished that, that's something that I really don't want you to write. There's so much extra stuff you have to write for that stuff that I don't want you to have to waste your time writing out a bunch of HTML-related stuff on an exam like this. The course learning outcomes are examinable where they're appropriate. I've been listing the course learning outcomes in the lectures that we've been doing at the beginning of each lecture. I've also been listing them on the course schedule, so you can take a look at those there. But I do promise to publish on the course webpage a document with the learning outcomes that are actually going to be on the final exam before the final exam shows up. I'll post this as a news item when I have that ready for you and it's available so that you can kind of focus your preparation efforts and not really worry about things that are not necessary for our final exam. All right, so I've got a question here that I want to ask for you. I'll give you about 5 more seconds to answer this question. We have been playing Cookie Clicker all term, and so I want to know what game you're going to play in your next course. I think I did promise that we would ascend. So we will ascend. We will lose all of our cookies here. And we actually didn't get any more heavenly chips, so I don't think we can actually afford to buy anything. So we'll just immediately reincarnate. And then we're back to nothing, but we have 10 cursors to start with. Okay. My son helped me with this. He's the one that suggested Subway Surfer. I've never played this game before. I don't know if you've played this game before. A bunch of you are nodding. Okay, yeah, okay. Subway Surfer it is. Okay, I'm going to let him know. Because he's going to be really happy with that. We got Pokemon. We got this Pokopia game. And I don't know. I actually don't know if any of you actually like Pokemon. I don't really care, I guess, at this point. It's too late. But do any of you like to play Animal Crossing? Some of you? Okay, so like we've been playing this Pokopia all weekend, and it is like, it is Animal Crossing. Like, I don't know. The art and the style of animations of the characters and stuff and like the emotions that they play back is is just Animal Crossing, to the point that I almost think that they just use the Animal Crossing engine under this game and they just put Pokemon characters into it. And so it's really fun and it's really nice, but okay, everybody's gonna play Subway Surfers in the next course. Okay, so now I actually do want to give you a chance to ask me questions about the final exam. As always, I'm also happy to answer any questions that you have verbally about the final exam. So the final sort of term test 1 and 2 merged together. That is a reasonable way to think about this, yes. There's stuff that has not been assessed on any tests at this point. So like the Markov chain stuff, the state machine related stuff hasn't been on any tests. So you should expect that to be on the final exam. But I think this is a reasonable way to think about the final exam, yeah. That is a very good question. I'm going to politely ask the room. I'm going to try to remember my best to do this, but I'm going to politely ask the room to just somebody send me an email. If I get 15 emails, this is my own fault, but please send me an email and I'll change the deadline for the course topics and the off-topic forum to be the day of the exam as opposed to April 9th. That was not on purpose. I was just blindly going through and changing everything to be the last day of classes. So please, somebody or many people emailing me about that, and I'm happy to change it. I am not going to have any office hours scheduled after the 9th, no, but I will take appointments. I should be on campus. I have other meetings and stuff going on campus, so I'll be around. I do have office hours tomorrow. I'll have office hours during class time on Thursday. I'll be on campus on the 9th. I'll be on campus on the 10th. I'll be on campus the following week. I'll be around, so if you want to meet with me, you can come and chance dropping in, but if you really want me to for sure be there, send me an email to schedule an appointment. No. So will we test how to read CSV files and transfer to JSON? No. And I guess I'm going to quickly pop this open here. So just because I want to make sure everybody has this idea, comp 2452 A01. So I've kind of said like you should load the stuff. You should load the CSV file in the same way that we're doing the DDL stuff, and I really mean that. So while parsing the actual content of a CSV file is something that you can do on your own, like string.split sort of thing. Loading the file should be just like this. So this was quite a while ago that we did this, so it's fair if it's something that's fallen off your plate. But the question mark raw at the end of this import statement just loads the file from disk into a string. So you don't even have to do like file manipulation stuff, at least in the context of running your application in Vite itself. If you're running this stuff on the command line, yeah, you'll have to open the file with Node, but at least when you're running it in vtest, you can just do it this way as opposed to having to do any other kind of complicated mechanism for that. But to answer this question directly, no, this is not something that I'd really be concerned about for this. So writing a program to implement it, I'm asking you to do that on the project itself. Writing a program to implement it is not necessarily something that I expect you to do for the final exam. This would be more of a visual abstract kind of representation of this idea on the final. When I have finished preparing the final exam, I have a term test I have to grade before I can prepare the final exam. And so I will post this as early as I can, but I can't post it before I've got it. So like I said, kind of abstractly, visually representing this idea. This isn't something I'm really necessarily looking to assess you on in terms of like implementing an adjacency matrix-based implementation of a Markov chain. This is something I'm expecting you to do for your project themselves, as opposed to something that you do in person on a test. Walter is, so I mean, over the weekend, Walter is like an indoor cat. He lives inside the house, but we let him outside. And when we let him outside, we put a harness on him, and we either lead him around on a leash, or more realistically, he leads us around on a leash because he's a cat, right? Or we have like a rope that we've got set up in our backyard so that really he just can't catch birds. We just don't want him to catch birds. But the rope in our backyard has been frozen under a puddle for about 6 months at this point. And so the rope is finally unfrozen, and now he's able to go on a radius of about, I don't know, 3 meters around the yard. And so he's just delighted. And on the warm day on the weekend, I let him outside, and he was just like, we say this about Walter when he kind of flops down on his side on the patio in the backyard, that there's just a furry puddle that's melted into the backyard. And that was definitely what Walter was looking like this weekend. The submission deadline for all course submissions is the last day of classes. So I put the last submission folder up this morning before I came to class today. I've set the deadlines for all folders to be 11:59 on Thursday. I guess the same thing with Markov chains. As when we were initially looking at this idea, you squint at a finite state machine and you squint at a Markov chain, and they look real similar to each other. In fact, the machinery should be the same between the two of them to go between states and stuff. I would be looking at this from the perspective of abstract visual representation of state machines and Markov models, as opposed to having to implement code for them. So I answered a question like this on the discussion forum, and I'm going to say, like, I'm not going to forbid you from doing this, but if you're using a library for this CSV file, you're doing way more than is necessary. Libraries like this are useful in cases where you're dealing with CSV files that are just like given to you from the wild. When I say the wild, I mean things like that it's got columns in it that have strings that are double quoted, and inside the double quotes there's a comma. And that's not a delimiter, that's like the string that's in that column. That's what something like pop-up parse is useful for. Here you can just assume that everything has one character and a comma, and that's it. And so doing just plain split on the string that you read in, that's going to be far, far, far simpler than using something like pop-up parse. Those libraries are valuable. Like, I don't want you to be misled by this idea, but using string split should just be faster, simpler, and better than using a library. Yeah.
I've been, like you said, importing it like the raw numbers.
Yeah.
I'm getting like a keep out of memory error.
So that will work with Vite once you've collapsed this down into like your matrix. You're right. If you try to import the 70 megabyte file, it's going to heap overflow because that's a significantly larger string than you'd want to be able to import. So I guess when I was saying that, I really meant more the adjacency matrix structure that you're getting from your command line tool that you're using to train the model. Yeah. So, I mean, I guess this is a fair way to think about it, yes. If it's all connected, you're unable to do one part of it, would it reflect the other portions? The term tests have already been structured like that, and at least as far as I can tell, there hasn't been like a major direct connection in terms of the results between one part and the other. Like some people were kind of missing some part of the first part of the MVC question on the term test, but they did fine on the other parts, and in terms of the outcomes that I was seeing. So I'm not really concerned about that, but this is a reasonable way to kind of think about the structure of the final, yes. This part, no. This is just going to be the last day of classes is the submission date for this. So using seed random in the project, you can see that I've kind of done this. You'll have to install this with a dependency management tool. You'll have to use npm to install this to get it to work. But I'll hold this up here for a second if you want to get a sense of what this looks like. Yeah.
By the way, like in our code, that seed must be fixed, or like we also generate it still?
The seed is something that you should choose as a fixed value so that you get that predictable sequence of random numbers that are generated each time you start your application app. My expectation is that you'd set the seed once when the app starts, but you'd never seed it again in the lifetime of your app. So like once you refresh the page, sure, you'll restart it, but once the page is loaded, you seed it just once and then get that same sequence of outputs every time you refresh the page. What you choose for your seed is entirely up to you, but I wouldn't generate that with a random number generator. A way to generate seeds for random number generators is often to use the current time. So like using a new date or something to get the current time. But again, the purpose of us using seeds here is to make sure that we have a predictable sequence of outputs from a random number generator.
Each time you restart it, it's again the same seed.
It would be the same seed and the same sequence. In terms of the state that you're starting at, I'd expect it would be different because you have some different starting state. So the outputs that you functionally see from your Markov chain will be different, but the numbers that get generated by the number generator will be the same. Yeah. So as with the last two term tests, I can't promise to give you any practice questions. The best way to practice is to work on your projects. I'm not going to say yes, but I'm also not saying no, but the likelihood of me being able to have time to generate practice questions is limited. Other ways to think about this might be not just to scale up the quizzes, but like to take the term tests that you've got. And again, I promise to publish the grading guide for the second term test once I've finished grading it. But take the term tests and spin them differently. Like you choose the domain, change the domain, and then just do the test again to see with yourself and self-assessment what you think it would look like. If you want to do something like that and you want to come and talk to me to get some feedback on what you've been writing for this, I'm more than happy to do that for you. No, it's not a problem. This is going to be more difficult to test if you don't have this seeded. Seeding is going to be valuable if you're writing a test to make sure that your Markov chain works. And the test that you're writing for your Markov chain really ought to be like, if I run the next thing, do I get the same next item every time I run this Markov chain using the same training data? If you don't have a seed in terms of a game, for example, that would be reasonable. Cookie Clicker, if it's worth anything, does kind of have a seed as part of the export save option and loading, like saving to a file and loading from a file. There's some kind of a seed that would be set as part of the operation of loading this game. Games like NetHack and other roguelike games, they always start with a seed because that's how they generate the dungeon, basically, is they use this random number generator to generate the dungeon itself. And they'll export that seed as part of that so that you can share this dungeon with other people. And it's using the same random number generator. So if you don't have a seed in your program, that's not necessarily a problem. It's just going to be difficult to test it from a testing perspective. The seeding stuff is not, but I can definitely do that after class today, yeah. I think I've answered this question already, so I'm going to skip past that. I think I've answered this question already, so I'm going to skip past that. Oh yeah, okay. So on the project itself, yeah. I guess I'd expect that you would be able to run this with Node. If you're training your Markov chain using TypeScript, then I'd expect you to run it with Node. Some students have told me that the most recent version of Node, you don't even have to compile the TypeScript. It just runs in Node. You don't have to do anything with it. My experience before the most recent versions of Node is that you have to compile your TypeScript file to JavaScript first, and then you can run it with Node. The main thing that I want to know in the README file that you're submitting to us is you tell us how to do it. You tell us how to get your code compiled and running in a state that we are able to do it ourselves. Rob has not met Walter, no. Has Rob been talking about my cat in his class? How am I? I'm doing okay. I have been doing course development work for 6 months. And in my 10 years of working here, I haven't had to do that before, and this is a lot. And so I don't know about all of you, but gosh, I am looking forward to summer. I'm looking forward to like riding my bicycle. I am like, so I told you a little bit about how I commute to work, and I do have a pretty long commute, but I also like to ride my bike like outside of commuting. And I pretty regularly go out. I ride my bike from about where I live, and I go out toward Portage La Prairie, and I get about 50K away and then turn around and come back home. And so like I kind of usually doing 100K rides or 125K rides kind of going out and around on this highway. And I really like being here with all of you, but I would so much rather be doing that. And so I'm looking forward to that. So I'm doing great. Like I'm looking at the forecast and thinking snow, and like that's awful, but also looking at the forecast after that and thinking, wow, I'm gonna go on a bike ride soon. So yeah. Yes, absolutely, yes. Okay, so the clicker game. The clicker game, I answered a question a little bit like this in the discussion forum, but part of my answer to this question is really just like mission accomplished. We don't have to play the game anymore because we're overflowing number as a result of setting up the auto buy thing. Like it's auto buying things so fast that the game is just overflowing. Awesome, good. We don't have to play the game anymore. We've beaten the game. That's really the point of it. So yes, that's fine. You can scale it back a little bit, but an embarrassing number, that's what I'll say. Yeah, okay, and I think I got that. So again, please like send me 15 emails so that I remember to fix that. All right. Okay, are there any last questions about the final exam that you want to ask in person before we move on to doing course review?
How hard will it be? How hard will it be?
How hard is it going to be? So this is a joke. It's going to be punishingly hard. Like you should expect it to be consistent with the term tests. I know that the consistency of the term tests was a little bit off. Like the first term test was longer than the second term test. I think we can all agree on that. I think we can all agree. And the nods I'm seeing are yes, we can agree on that. Yes, the second term test was shorter than the first term test. The time that's allocated for the final exam is longer than either term test. Scaling that upward, I guess you can kind of expect it to be kind of in the middle. Yeah, I think, yeah. All right, okay. I'm gonna go back here. Let's do a little bit of review. I asked you last time to rank the topics that you wanted to take a look at. And so I took the top 3 topics that you wanted to take a look at, and I want to spend a little bit of time looking at those today. So the top thing across both sections was to look at architecture. The second thing was to look at Markov chains, and the third was to look at SQL injection. And so that's the order that I'm going to go through here. I wanted to start this by reminding you of the architecture that you saw in Comp 2450. The architecture that you would have seen in Comp 1010 and Comp 1020 is more just like question mark, question mark, question mark, and there is no architecture because you kind of just threw code together and got the solution for the problem and you went from there. The architecture that we actually used in Comp 2450 was this N-tier or layered architecture, where we had each different layer of responsibility communicating with other layers of responsibility. And horizontally here in the diagram that we've got with the classes that we had, each of them had kind of a main responsibility that it was supposed to do and not really kind of do other things that it's not supposed to do. So we had this UI layer. The UI layer was responsible ultimately for doing things like getting input. So using scanner. This is where somebody would actually sit at the keyboard and type stuff in here. Once we got this input, the UI layer's responsibility was to then start to go through the process of constructing domain model instances. And for that, we were using the builder pattern. Part of the use of the builder pattern in this class was really about making sure that we could retain the state of partially constructed objects. And this was necessitated by the fact that when you're typing stuff in on the keyboard, you can only respond to one prompt at a time. You can't kind of partially save the state that you've got as you can in a UI where you can just have a bunch of fields on the screen at the same time. So we gave the responsibility of constructing the classes to these builders. The builders were responsible for validating things. And ultimately, they gave us an instance of a class. And we were able to use that to then ask the logic layer here to do stuff. So we were using these domain model instances to communicate between the UI and the logic layer. The logic layer itself had this responsibility. This is where all the logic of the system happened. It would either make changes to its own internal state, or it would make changes to the domain model objects, or both of those things would happen. The logic layer didn't print anything. It didn't get any input. All it did was make changes to things. The final thing that we added in this course was our persistence layer, and our persistence layer had purely the responsibility of taking these domain model objects and effectively transforming them into some other structure. So in this case, they were responsible for transforming it into strings. Here with our persistence layer, we were implementing the adapter pattern. We were adapting our domain model instances out to JSON. We were adapting them out to strings. The persistence layer also had the responsibility of loading things back from disk. So reading those files that we had written to disk and transforming them back into domain model instances. We would pass those back to the logic layer where it was appropriate, and then the logic layer would return all of this stuff back to the UI layer to print results or print errors where it was appropriate to print those things. In 2452, we kind of took something that looks like this layered architecture. We still have things that have responsibilities, but the way that these things are connected to each other is a little bit different than the structure that we had before. So with MVC, we've really taken this layered architecture and moved some things around and kept some things the same. The view in our MVC architecture is really functionally the same as the UI layer. That's where we're getting inputs. This is where we're asking other things to do stuff for us. But beyond getting inputs and asking other things to do stuff for us, our view isn't really doing anything. There's lots of CSS and stuff that we might be adding here, but really functionally, all we're doing with our view is asking the domain model objects to tell us what their properties values are right now. We're just displaying information about some specific thing that we're responsible for printing out. The views also have some methods or mechanism to interact with this thing that's called the controller. In the MVC architecture, the controller's job is to accept those inputs and really make decisions about what views should be on the page right now. So it's accepting the inputs that the views are giving to it. It's asking the domain model instances to change themselves. And then based upon that, it's making decisions about what views to show on the page. So our view has buttons. We click on those buttons to ask the controller to do something. The controller then is either creating instances of these views or doing other stuff with the views so that what we're seeing on the pages is changing as that time goes on. The controller is interacting with our domain model objects. And here's where we've taken many different ideas and kind of smushed them together compared to that layered architecture. With the model, what we're doing now is we're doing the domain model itself. These are the properties that each of these different things has. But we're also giving the responsibility of logic to this domain model part of our MVC. So anything that's going to change the state is going to be encoded inside of this domain model part of our architecture now. It's also got the responsibility of doing persistence. And so it has the responsibility of doing things like asking, I'm going to save this to my SQL database right now. I'm going to load these things from my SQL database right now. And all of this is kind of pushed into the model. The model itself implements this, this listener pattern. The listener pattern was something that you saw in Comp 2400 for the first time, and then we saw it again here. And the listener pattern is really about making it so that the model is able to tell interested parties, that can be really any of the model, the view, or the controller, that something about its internal state has changed. In most cases, this is going to be the view. I want to update the view because the value of this thing has changed. So I need to tell that view to update itself that this thing has changed. I might be telling myself that something about me has changed. I might be telling other domain model instances that something about me has changed and you should update yourself. And so that's the way that our model is then interacting with the view part of our application here. So I really wanted to take this diagram and quickly update it with a couple of additional items here. And so I'm going way back in my tablet, and I'm going to restart this. But what I wanted to do here really briefly was to add a couple of things here. The first time we saw this, I mean, we were in the first couple weeks of classes. This is, well, I drew this diagram twice. And so this was like, this is the first diagram that we drew in the class related to architecture stuff. And so I wanted to really briefly add some of the stuff that we have added to this course as a result of what we've accomplished so far. And so the persistent stuff here, this is really about SQL stuff. So in our domain model, this is where we're doing things like selecting and updating records that we have in the database that represent those main ideas that we have in our system. The other thing that we've added kind of informally to this is that idea of inventory. And the domain model is responsible effectively for telling us these are all of the available instances that we have of this type. For the logic, one of the main things that we've added in the last couple of weeks here is really this idea of the Markov chain. The Markov chain is an implementation detail of the domain model because it's really part of the logic of the system that we've got here. The controller and the view can ask for things to come from the model in the form of the view can ask for properties of the view, and it can listen for changes, so using that listener pattern. But in terms of the Markov chain's actual implementation, it really all belongs in the domain model because it's something that is kind of core to the implementation of the model itself. One thing that you can reasonably add here, we've got this listening for changes coming from several different parts here. So we've got the controllers are possibly listening for changes. The views are listening for changes. But we could also have our model listening for changes. It's reasonable for different domain model instances to notify themselves through this listener pattern that stuff has changed about these different properties of the classes that we've got. The controller really still has these same responsibilities. It's about kind of coordinating between the UI and the logic. It's responsible for deciding what views to show based on the conditions that have been returned or thrown or whatever by the model. And the view is interacting with that really just by calling methods on the controllers on button clicks. All right, I'm going to pop back here to my Mentimeter. I've gone back to the slides. And so I've got another slide for questions about MVC architecture. But it's for some reason the same questions that we had before. That's fine. Are there any questions about MVC architecture? Yeah.
Could you explain like this so the metric for the model, like when out?
Absolutely. So the model can reasonably listen to itself. A prime example of this to me is for the clicker game. So this is kind of focused on that specific project stream, but the only way that you can buy anything is if you have clicks. You can't buy something if you don't have clicks. And so it would be reasonable for the model to listen to itself to know that the number of clicks has been updated. It's already notifying the view that the number of clicks has been updated using that listener pattern. And so the game state, the thing that's responsible for doing the auto buy operation, could very reasonably just listen to itself. So rather than having some separate auto buy feature that's like interval based, that would be a reasonable way to do it. But rather than, or instead of doing this interval based auto buy operation, you can listen for changes to yourself. And if you notify yourself that these changes has happened, then you can do the auto buy operation kind of when that's happening. Yeah. That's a specific example, but this is really something you can do quite broadly across other kinds of domain model instances that you've got. Yeah. Yeah.
So like the Markov chain implementation, I was thinking that it should probably be like outside of either of these three parts, because they did like implement it separately and then it just like compiled separately. So it should like actually be like part of the model.
The training should be separate from this whole application. Like the training shouldn't be part of this architecture at all. But the actual use of the Markov chain, once you've got that trained model, really should be part of the domain model itself.
So they're kind of like located in a separate package.
Sort of, yeah. You could put it in a separate package, but you could also reasonably put it as an implementation detail of the class that is responsible for doing the auto buying in the first place.
It's another question kind of specific to thinking of the building system, but just in general, any time we want to set an interval that updates the domain objects, so often, which later does this belong? Because to me that was a logic.
The set interval thing to me belongs in the view. And at least in the case of the clicker game, I'm going to justify that by the idea that what we're simulating is a user interaction, and all user interactions really belong in the view. Both in the case of auto buying and in the case of auto clicking, the set interval should really just call the click method, the exact same click method that gets invoked by clicking on the thing. And so for that reason, to me, it belongs in the view. I'm also going to say that it's kind of challenging to test set interval-based stuff in your logic and domain model implementation without putting arbitrary delays into your tests. And arbitrary delays in your tests to do set interval-based testing is, I mean, it's fine, I guess, but it's pretty fragile. If you, for any reason, change the rate at which things are happening, now your tests are going to break for unrelated reasons. It doesn't mean that your stuff's not working. It just means that you changed something in a way that your test wasn't expecting it to. And so that even further says to me it belongs in the view because I don't really want to test that in the same way that I'm testing other parts of my domain model implementation. Yeah.
So like, this is my understanding. I just want to make sure it's correct. Like when we're using the auto buy, we're providing some amount that it's going to fill with the products that it will suggest.
For the point of sale system, yes. So you're basically going to say you have a budget of $500, spend $500 as much as you can. Eventually, you can't spend any more because you either can't afford the next item that's generated by the chain, or you have actually run out of money. Both of those really are the same thing. You can't afford the next thing in the chain, but yes, you get a budget and you kind of proceed through it. Yeah.
This is not really about the model. You mentioned testing the Markov chain. Are we expected to do that? Or this?
That's not part of the rubric, no, but putting tests in that evaluate your behavior is going to give you confidence that it works when the grader opens your work. That's the value that you get out of testing this in this case, is that you are confident that no matter what happens, that it's going to work when it opens on somebody else's machine. Yeah. Yeah. So that's a fair question. How do you know if your Markov chain is correct? And part of my answer has to be, you can step through the Markov chain yourself. You know what the adjacency matrix looks like. You can kind of step through this by hand and on paper. And as tedious as that is, it's going to give you confidence that your implementation actually works based on what your understanding of it is. And also you can write tests. You can write tests based on that. Like I've run through this on paper. I know that this is what the next thing is supposed to be. I should expect that that is what I actually get given the seed that I've got and the sequence of random numbers that I get. Yeah. Any other questions about architecture? All right, okay. We've now looked at two different architectures. And the places that you can expect to see architectures next in your path through a major or honors computer science degree, and in some cases the joint degrees, but not all of the joint degrees. The next place that you should expect to see this is in Software Engineering 1. Software engineering, to me, this is kind of one of the main pillars of these two courses, is that we're trying to shuffle you towards what is going to happen in software engineering. In Software Engineering 1, at least as it has been taught for quite a long time, what you're going to see in that course is a layered architecture. One of the major problems that I've seen lots of students having in that course is that they will elect to separate work among their team because this will be a team-based project as opposed to an individual project. They try to distribute work among their team by giving layers to people. So like you are responsible for the UI, you are responsible for logic, you are responsible for persistence. And every time I see students do that, they fail very badly. Like not fail the course badly, but like they kind of like crash. Their team collapses on itself and they get angry at each other. You all now have experience building full stack architecture. You know about these different layers and you know about two different architectures. You know all the different parts of this. And so the way that I want students to work in Software Engineering 1 is to do feature-based implementation. You build the entire thing. You build the UI and the logic layer and the persistence layer for this thing. And you are all fully capable of doing that now before you get into software engineering. The other stuff that this course talks about is going to continue talking about solid. We have talked about it less in this course, but more in Comp 2450. This course will also further testing. In this course, you're going to do UI testing. This is not going to be limited to the domain model and logic stuff that we've been doing in this course. In Software Engineering 2, you should expect to see more architecture stuff, although this scales it up even more. In Software Engineering 2, what you can expect to see is like not just a single application that does the layered architecture, but multiple applications that are connected to each other. So often what we're asking students to do is on teams of 6 or 7, build a mobile app that connects to a server, and the server itself also has the layered architecture implemented underneath of it. The other places that you can expect to see architecture stuff are at your day job. You can absolutely expect to be using some kind of an architecture. I can almost guarantee that you will see the layered architecture in your day job. It is pervasive to the point that I believe it is almost 100% guarantee that you will see this in your day job at some point. You will also often see MVC, but most likely you're going to see the layered architecture here. Depending on where you're going after you graduate, a course where you might also see something like this is a course that's offered by Xiaowei. This is called Data-Driven Software Engineering. This is a grad level course. Our grad level courses are sometimes cross-listed as undergraduate topics courses for honor students. So this is something that if you are in 4th year and this is being offered to you and you are in honors, this is a possible course that you could be taking as an elective at the 4,000 level. But this is also something that's offered by Xiaowei. I'm not actually really sure what he talks about in this course, but it is a software engineering course where I would expect you to see some kind of an architecture. Okay, so the next topic that was requested was this idea of Markov chains. And I wanted to share this photo of Andrei Markov, who was the fellow who like kind of put together the stuff that eventually became what we are now doing as Markov chains. And I guarantee that he knew that we'd be doing sandwiches with this. But Markov chains are really this statistical model that represents ultimately the frequency of pairs of output and training data. That's really what we're modeling with a Markov chain. The pairs are often connected to each other in bigger than just units of 2. But really what we're modeling with this is the idea that I've observed this same thing more than once. I've observed this thing more than once, and based on the initial state, this is how many times I've gone to these other states. Really superficially, our idea of Markov chains are that they are similar to state machines in that they have states and they have transitions. There are nodes and there are edges between the nodes that we've got. You've seen this in Comp 2400 already in terms of state machines. You will have implemented some kind of a finite state machine for this course. And in this course, we saw this applied to doing things like validating inputs. So using state machines to validate email addresses. And for those of you that are in 2280, I believe you also saw a very similar state machine in that class as a result of doing this, but not everybody is in 2280 at the same time. So what I want to do here is kind of quickly take a look at our Markov chain, and we're going to spin past through a lot of stuff here that's duplicated, and I want to get to our state machine, and I'm going to go to this one here. Our state machine here is our sandwich-based generation of data. And what we trained this state machine on was the words that we have in the language that are consisting of the symbols that are in this language. The symbols in this language were the toppings that we put on our sandwiches. So peanut butter and bread and jam and ham and cheese. What we were making observations about here was the training data that I've got at the top. And really what we were modeling with this was, this is what happens when you go from here to here. This is how many times I've seen this transition happening. So for each of these, we were trying to say things like, I've seen this bread to peanut butter transition. That's what I was trying to model in this Markov chain. I have seen this peanut butter to jam transition, and I've seen this jam to bread transition. And the way that we modeled that here was to add edges between the states. And we were keeping track of how many times have we left the first state in this pair, and how many times did we go to the next state in this pair. As we built this up, we kept going for each of these different pairs in our training data. So our second word was bread, peanut butter, and bread. And then we had bread and then lots of peanut butter and bread. And then we had ham and cheese sandwich at the very end of this thing. We also then represented this as adjacency matrices. And our adjacency matrices are really representing the same thing as what we've got in that visual diagram. For me, it's a lot easier to write code that works with an adjacency matrix than it is to write code that works with the graph structure. You are very welcome to implement this as a graph structure if you want, but it's a lot easier for me to reason about this in code. With the denominator, when we originally wrote this, we were using a full matrix, but as we saw with observations here in class, the rows all had the same value across them. So like the number of times that we left the bread state, it had 5 across it the whole way. And so we're able to reduce this down to just one vertex here. One vector. So to represent just this array of values that we've got. And really what we're trying to represent with this is the number of times I left the state. And it's really what we're trying to represent with this is the number of times that this symbol was the first in the pair of the data that we're looking at with the training data. So what this really says is that we have left the bread state 5 times in the training data that we've got. That's really what we're showing with the denominator here. I left the bread state 5 times. With the numerator matrix, what we're showing is I've left that 5 times in the denominator state. In the numerator matrix, we're really trying to say, this is how many times when I left that state, I went to this other state. And so the 3 that we've got here is really trying to say that I left the bread state 5 times, and 3 of those times I went to the peanut butter state. That's really what I'm trying to show here. I left the bread state 5 times, and of those 5 times, I went to the ham state twice. That's really what I'm trying to show here with this. These other edges that we've got, so the bread to the start state, the bread to the bread state, the bread to the jam state, the bread to the cheese state, these edges technically exist in the model that we've got. We didn't draw them here out of convenience, but there is a line between bread and cheese. There is a direct line between bread and cheese. It's just 0 times. We've never made that observation. And so it's a lot easier to not draw the line than it is to include it here and make this more clunky. But in our adjacency matrix, we're still saying, I've never seen any transitions between the bread and the cheese state directly. So I left the bread state 5 times, but I never made that observation to go to that bread state or to the cheese state. One thing that you can take with this structure, if you're thinking about things like design by contract, is that the sum of the values in each row should be equal to the denominator. You have to have a 100% chance of leaving this state. So the sum of the values that you have in this bread state going to all the other ones should be equal to the value of the denominator in the bread state. It should be a total of 1 out of 100% chance of leaving the state that you're in. In terms of deciding how to go to that next state, or which next state that we would do, we have this little algorithm here that's going to help us decide what to do, where we generate a random number between 1 and the denominator. So we've got the denominator in that vector of denominators. And we're trying to use that random number to make decisions about what state we should move to next. The way that I'm suggesting that you do that and kind of how you implement this internally is up to you. But what we're really trying to say is I'm going to go through every possible connection that there is leaving the bread state going to some other states. And I'm going to keep track of the total number of exits that I've seen so far. Once I've exceeded that random number, that's the state that I'm going to choose. So if I'm iterating over this bread state here, and I generate some random number that is something like 1, then what I'm going to do is, starting at I equals 0 here, I'm going to say, is the total value of all of the states that I've observed that are next to the bread state greater than or equal to 1? There is no edge from the bread state to the start state, so I change my I to the next one. My I is now 1. The transition I'm looking at is the bread state to the bread state. I add this to the sum that I've got. And I ask if that's greater than or equal to 1. It is not, so I move to the next thing in my row here, and I add 3 to this. And 3 indeed is greater than or equal to 1. And now my I is equal to 2. And so really that's saying to me, you go to the peanut butter state for the next state that you've got here. All right, I'm going to go back to my slides, and I'm going to... We've got a little bit of time for this, so I'm going to give you a chance to try this. I'm going to give you about 2 minutes. I'll give you 2 minutes to do this. What I'm asking for is, here is the model. This is the same model that we have on the screen there a moment ago. I'm giving you a stopping condition. Our Markov chains don't really have start states and they don't really have end states, but we can decide to stop emitting output from a Markov chain. The stopping condition here is that once you have seen 3 pieces of bread, you should stop emitting output. That's what I want to be able to do here. I'm giving you a sequence of random numbers, and I am telling you what the starting state is for us, but there is no formal start state in this Markov chain. I'm just telling you what we are going to start with for emitting output here. I want to know, given these conditions, what is the sandwich that's generated by this Markov chain. And I'm going to give you a tip, and the tip I'm giving you to make sure that we're all consistently generating the same output from this model is that you should take this model and build an adjacency matrix with the state order bread, peanut butter, honey or jam, ham, and cheese. So make sure that it's in that order when you're doing that. So I'm going to put about 2 minutes on my timer here. And I'm going to do the same thing just beneath the diagram that I've got here. You need 30 more seconds? Okay. Of these four, which would we get? I'll give you about 5 more seconds. Okay. All right, good. Yes. So I guess the first key to note is that we've got the stopping condition. And the stopping condition that we're trying to stop on here is that we've got 3 pieces of bread. This is our main stopping condition here. And so that one actually will immediately make this one kind of go away. There's 5 pieces of bread in this, and so we're not going to generate any more output once we've seen that last piece of bread that puts us up to 3. This one could be reasonable if the random numbers actually did get us stuck in the peanut butter state. That could be reasonable. We could just keep generating peanut butter forever. But in this case, the random numbers that we've got won't get us stuck in that peanut butter state. So that kind of leaves us with these 2 options here. And the best answer here is that we're going to go from the bread state to the peanut butter state based on what we've got here. So I'm going to slide over to my slides here. We've got this random number sequence in the problem that we've been given. And we're starting here in the bread state. Our first random number is 1. And we're going to then run over all the edges that we have as output, or all the transitions that we've observed, until we exceed this random number that we've got. That means that we're going to emit bread to start. That is our starting state. We're going to start here and look at this. 0 is not greater than or equal to 1, so we move to the next possible output. 3 is greater than or equal to 1, so our next output is to go to the peanut butter state. Now we're in the peanut butter state. Our next random number here is 1, and we're going to do the same strategy. We're going to look at the next outcome of this, so the next possible state at I is equal to 0 in the row that we're looking at here. Our random number is 1. The value that we've got here is 2. That means we're going to take this transition. And so our next output that's emitted is bread. That takes us back to the bread state again. Our next random number that's generated is 1. The same thing's going to happen as in the first time that we stepped through this. We're going to get to the peanut butter state, and that's when we will exceed that value. So we'll print out or emit the peanut butter state here, and we'll go back to this peanut butter state. Our random number here now is 2. We're going to stop at the same state again here because in this case, 2 is greater than or equal to 2. And so we will move back to the bread state one last time. And that's where we're going to stop because that's what our stopping conditions are for this. I'm going to see 3 pieces of bread and I'm going to stop emitting output from this model. Any questions about that? Good? Okay. Hungry now, I hope. Okay, all right. The next place you can expect to see something like this is in the machine learning concepts and usage course. This is Comp 3360. The detail that you go into with Markov chains is going to be higher than what we've done in this course. It's a 3000 level course, so you should expect that to happen. You're going to start thinking about things like the actual statistics that underlie what these models represent. We really haven't in this course. Like, you're going to be thinking about things like the probability of state xj given xi, and you're going to actually answer those kinds of questions about these Markov chains. You'll also talk about lots of other kinds of ML algorithms and data structures that we haven't talked about in this course. You will also then see this more in courses like Comp 4360, which is the next machine learning course. You might see something like this in your day job. Although my expectation is that you would be more of a user of something of this than actually implementing these kinds of things yourselves. Typically, we wouldn't expect people working in a job to implement Markov chains as part of what they're doing. They would use a library to help them accomplish those kinds of tasks. There's also some grad courses. Chris Henry, Sogand, are people that are doing research in some ML related stuff. And I've talked to you about both of those, although Sogand, I was talking more about security, but she also does research in machine learning. And John Braco asked me to pitch this at you, and so I'm going to say sorta. You'll sort of see things like this in computer graphics 1 in the form of like state machines. In the form of matrices. Graphics is all about matrices. He also asked me to pitch this to you in the perspective of Comp 3490 is offered in the summer. It's currently not full, and the prerequisites are this course and Comp 2140. I don't know if that sells it for you. I think it's a cool course for the records, and I think many of you had John as an instructor, so yeah, John will be teaching that course. Okay, the last thing I'm going to talk about here is SQL injection. We've got just about a minute left, and so I really just want to kind of put it out here as this. This is really about using untrusted user inputs in string concatenation or template-based construction of queries. And so if I'm giving input directly from a field into a query, that means that I have control over injecting things into that query. So given the first query that we've got here, and if I just type in this string in the field that I have the ability to enter, the actual query that gets run is going to consist of more than one part here because I've injected the string into the query. We really solve this using parameterized queries, really by taking this idea of the query and the data that go in the query are separate things, and they're physically sent as separate things to the database that we're working with. All right, so in summary, Both of these courses have been about the development of software. And what you have accomplished in the last 2 terms is you built larger, interactive, both text-based and graphical applications at this point. You've done a lot of software testing, and in both of these courses, we've done data modeling and thinking about our software in a way that's a little bit more broad than just us building our software. We're thinking about things like how people are starting to actually assess. I guess it's the end of class. Thinking about things that are more broadly than just us building it ourselves. This is both from the perspective of like people like our parents using our software. So how are we assessing the UIs that we're looking at, but also things like how is our team going to interact with our software after we built it? And this is thinking about things like using architectures and making sure that we're using predictable practices in the implementation that we've got. In the very first class at Comp 2450, I had you read this aloud. I didn't read this aloud to you. I had you read this to yourselves. And I'm going to give you a moment. I'll give you 30 seconds to read this. I still think that this is true. I still think that this applies to this course. And I really think that this goes beyond this course. You know, the main thing that I want to say about this is, like, you're going to have connections to people. You're going to have connections to your team. You're going to have connections to the people that are using your software. You might not know about those connections, but in some way you are affecting other people positively and negatively in some cases. And so I want that to be an important part of what you're thinking about as you proceed through the rest of your academic career and your career after that. This is, again, our last lecture. I've been seeing you a lot for the last 6 months. I want to wish you all the best of luck on your exams. I want to wish you the best of luck in courses that you're taking after this. I probably won't see you again unless you take operating systems in the winter of next year. And I might see you in winter 28 or fall 27, depending on where you're going with your courses. But that's it for today. I hope you have a great rest of your day, and I'll see you all next time. Bye, everybody.